Okay, hello. So, oh, it's not showing up yet? There we go. Okay, so my talk is OP is overrated and ways you can build modular code. And as you can see, it's a very programming talk. So I was just curious, who here programs? Cool. Okay, who knows what OP is? Okay, that's pretty great. So basically, OP is object-oriented programming. And as you can see here, there is a question mark because I do think that there's a lot of use cases still. But the focus of this talk is more about ways you can build modular code. Because OP is more, I'll get into more of that, but it's basically a way to organize code. And I think there's ways that you can build much more modular code, and there's a lot of advantages to that. So anyway, first I will just introduce myself. So I'm Isa. I was a senior engineer in Microsoft. I work in the Visual Studio debugger team. So I was making the Visual Studio debugger, especially C# and C++. But now I'm no longer work there. Now I have been full-time on Coldblood Inc, working on my unannounced game. And I have started Modular Engine, which is my own custom game engine. It's open source for 2.5 years now. And another thing about me is that I love systems, I love architectures, I love designing, and this is one of the motivations for this talk, because I love talking about it and just letting people know about stuff. So, okay, a couple of disclaimers. So these are no rules. This is just my experience that I want to bring to people. And it will be very technical. So I'm sorry if you don't follow some of this, but again, it's like 20 minutes. So, and I do like being very deep into some of things. Like I love when talks just cover a little bit of like deep stuff. So I try to do that in this as well. So let's start by just saying, okay, what exactly is OP? So most people here know already, but I just want to cover the basics. So basically it's the concept, it's an abstraction. It's a concept of objects that contain data and code in the same place that interact with each other. So for example, languages like C, they are not OP because you cannot have structs that have methods, like you cannot have both in the same place. They are, but like other languages such as C++, you can have both data and code like in the same thing. And the way it has been so popular especially since the 90s or so, it's because it scales very well on large teams. So you have these big corporations and there's a lot of teams and they need to communicate with each other, and OP is a great way of doing that. But one thing that I found, especially with like newer software and like lately, is that I don't think the programs themselves are the problem that make it complex. I think it's humans. Like humans are complex and there are so many different teams. And I think that's one of the drawbacks around OP is that it kind of standardize a way for them to talk with each other, but it also makes things so complex. And for one example is that when I was learning programming, I heard about design partners. And I thought this was like this magic thing because it was just basically some rules ready to go so you can make like very fancy programs. And I have some examples of design partners. So singleton, so when you have a giant class with 10,000 lines and it has like a field instance that is static and you only create that once, that's usually a singleton. You have factories, which are basically a method that create other classes for you. Or you have builders that also wrap stuff up and build stuff. So you have all these things that basically make, oh, these are advice on how to build code. And one example of classic OP is something like, oh, Unity, for example. You have a player component that has health. So you have current health, max health, and then you have a method. So you have data and code. And then the method just implements whatever player does. So what is this talk about? So again, I'm going to show you ways you can build modular code. And the thing about modular code is that it usually takes longer to start with something. So you don't have something right away. It usually takes more time, but it helps you finish. It's much easier to finish a project if you structure your code in a way that's more modular. And the way I can show you that, so in the left, you have something that is very OP heavy. And that usually, like the code usually looks like a chain of like blocks that depend on each other. And on the right is something more modular, that things don't depend on each other. And let's say that I want to change one of these blocks. I want to change the implementation. And here, I want to change this block here. Here's what it would be on the left and the right. And these are the code that is affected by this chain. So basically, this one change had a lot more blocks being affected on the left, while on the right is just one single block. And you can see that I still have some inheritance in the right. So it's not that I completely avoid it, but it makes things much more horizontal. So again, what does this talk about? I will talk about 4 different things you can do to make your code more modular. And I will cover each of these topics. Oh, yeah, okay. It's a bit formatted weirder, but you get this thing. So the first one is entity component system. So who here knows about ECS? Awesome, okay. ECS is this magic thing that I love. It's mostly like the thing that got me into game dev, because it's a way to get into very data-oriented approach. So again, OP is a way to organize code. This is another way of organizing your code that's data first. So the classic OP, people usually call it just entity component, because the component implements the thing. But in ECS, the component is just a bunch of data and there is no code. And then there is actual code that passes through all this data. So I will show you an example. So you're making a game. And the first thing you have on the game, you have like a little guy, right? So you want to mix up with this little guy. That's games. So in OP, you can have something like that. So you have an entity, and then entity with health, entity with owner, entity with force, and finally a character. And the character is just inheriting all these things that you already implemented in other things. So you have this chain, right? And you usually would implement this character, something like, oh, this character is implementing entity with force. You have data like sprite or position, and then you override the update and draw. And then that's how we basically implement the thing in the game. In ECS, you can see there is no chain here. You have just an entity, which is basically nothing. It's just pointing to components. And these components, they just have data. So it's like this, like position component. This is just my implementation of ECS. In C#, this is just an example, but position component has a vector, and sprite, again, has a sprite ID, and there's no code here, right? So, okay, how do I display this on the screen? So like there's another system, so usually like render sprite or something like that, that will get all the entities that have these 2 components, and then it will actually show them on the screen. So they don't care about who these entities are, if it's UI, if it's enemy, if it's the character. It will just display sprites on the screen. That's all it does. So that's why it only watches for these 2 components. So what is the problem with OP? So here I have this, right? But let's say that I want to change how it receives damage. So if I want to change how it receives damage, I would usually go to entity with health. And just so you can see, like, I'm not making this up. So like, I took this example from Factorio. So they have like every Friday they did like a devlog, which it's an amazing game, and their devlog is fantastic. And they did screenshot like their inheritance chains, and this is basically very OP, right? And this is where our character is. So I basically used whatever they did, just to this example. And the one thing is that if I want to change entity with health, let's say that I have virtual void on damage received, then suddenly I would have to keep track of all these different implementations and make sure they don't break. And not only that, but we have all of this. They are all affected by entity with health. So it gets a lot, so it gets very fragile. And I know that Factorio, for example, they invested a lot in unit testing, so they can make sure it doesn't break stuff when you change, but it does get way harder. Now with ECS, what I would do, I would probably change health component or something like that. And then again, health component would just be, oh, I have health, max health. Maybe I can add something else, but it's just for this component. And then again, I would also have a system. So I could have like damage system, and I could just modify that, but it doesn't spread towards the other components. It's very scoped to this one scenario. So it gets very like, it's controlled environment. So one example here, this is like my custom engine, and all of this are components. So there's no code here, it's just data, just pure data. And here you can see health is there, so it exists. But it's like, it gets very horizontal as well. And just some examples as well is that it gets so horizontal and modular that I can just disable systems entirely. So like I disable the agent, or I can disable just a tile map rendering, and it doesn't break anything. I can continue playing because they are decoupled. They are not depending on each other. And just another way of showcasing that. So again, the whole point that I really like is, yes, is like, it's all about flexibility. You're giving yourself room to be creative. And most importantly, you can quarantine your weird code. You're making sure it doesn't spread towards the other things. It keeps being there. So as another example, like in ECS, I use coroutines, and coroutines for ECS that I made it work, it's basically components that have code in it. And that's basically the opposite definition of ECS, like that's just OOP again. And here you can see that I iterate over components and then I call them, and that's illegal. Like they usually say you don't do that in ECS, but it's fine for me because it doesn't spread towards the other systems. And if it's a problem, it's very contained. And then I can do super creative code, like just classic routines and make it fast and quick and not make a fancy system around that. So the second thing that I want to talk about is generating code. So generating code is basically writing code that writes code for you, right? And if you start generating your code, you get a code that is very fast because most of the time you can just look up stuff and information. So it's ready to go in the runtime. You have very clean code you can format, so it's pretty and it has like not a lot of words and it's contained. It's safe because it doesn't really depend on the size of the code. It's built to scale. That's the whole point of generating code. It will work for small code and for large code. And it's cheap. And I know that it's not cheap to implement it. When you implement, you spend a bunch of time. But after you finish implementing, it's just a no-brainer. And it gets so cheap to like remove stuff, add stuff, because it's all being generated anyway. So you're not losing assets, really. And just one example of where I use code generations is accessing entity components. So for the ECS thing, I could either do something without code generation, which is like get component, and then I put the component name, and then I get it, which is very slow and it's kind of ugly. Or I can get a get position, which is pretty, and it looks up, like it already caches the position integer, whatever, and it's just nice to work with. And it does something more or less like this. And then if I just delete a component entirely, it will just fix everything up, and it's all ready to go. Another example of where code generation helped me a lot is on code serialization. So I don't use reflection, for example, for serializing. Everything's code generated, but I didn't want to like to choose every class that is going to be serialized because I would have to think about it while making the game, and I just wanted to make it transparent as possible. So I did a code that automatically picks up all the classes that are going to be serialized, and that code is generated, so it generates the thing that is going to serialize them, and it just gets a no-brainer. And whenever I build my project, I can see if everything's being serialized correctly or not, because that's a compiler error, and it's just very nice to work with. And I wrote a blog post. It's very huge because this was a lot of work, and I mostly wrote it so I don't forget, because I mostly forget everything I did. But it's so useful. The third thing are game assets. Okay, what are game assets? Game assets is basically the way I serialize data. So again, I have a custom engine, so I just do something like a game asset that has an ID. And okay, this is very vague. Like, what does that mean? What is a game asset? Okay, everything is a game asset. So a world or a scene is a game asset. A prefab is a game asset, or a sprite is a game asset. And they're like, okay, but what do you mean a sprite is a game asset? It's a PNG, like why would it? Well, okay, so game assets are just a text file, and you can choose the way to serialize whatever you want. I use JSON. For example, for a sprite, I have the a sprite metadata, and then I use that to generate an atlas PNG. And then I have a game asset that basically says the name of this A sprite with where it is in the atlas, and then the ID. And this is the ID that I use. So if I rename that, it doesn't matter because I'm using that ID. And then if I have a prefab, it's also fine, like I have a name. I can reference to that sprite earlier just by using its ID, and then I can have a different ID for this prefab. So again, the reason I really like them, it's because it's super easy to rename files. It's easy to serialize and deserialize. I expect everything to be a game asset. Data does not become centralized in one place. Data are always carried throughout different game assets that I have. And it's very quick to visualize. I can visualize them in the editor in the way I want. And you can also notice that game assets is very OP, right? It's basically things inherited from game assets. And that is fine because the whole point is that I want to leverage OP where it's strong, right? But I don't want to use every little thing. But here it's very good. And the last thing that I want to talk about is reflection. So reflection is great. It's basically meta programming, the way you can think about it. It's basically like you can get fields of your class with the string, and then you get access to that field. And that depends on the language. So in C# it works very nicely, except that there are some problems with it. It's very wasteful and it's very slow. And yeah, you don't want that in the game. You want your game fast, you don't want it allocating memory. But the one thing in game dev is that if you're on the editor, then it's kind of okay to have wasteful or slow code, especially if that saves you like 20 minutes of your time, which is why I use so many of reflection and meta programming, because reflection allows you to do so much runtime logic, and that gives you so much flexibility, because suddenly I don't have to keep the name of the file, 5 different files. I can just start running my game and it will automatically pick up like with reflection on runtime. So I have some examples. So for example, I use it. So let's say I have a string, and that is a string that I use for localizing strings in my game. And again, that has an ID because that's the ID that I'm going to look up depending on the language. But I don't want to see that in the editor. I don't want to see a weird ID. I want to see the actual string. So the way I do it, I declare an attribute that say that this is a custom visualizer for this type of localized string. And that allows me to visualize the localized string as just text. And then in the editor, I just see the text directly. Oh, sorry. And then I don't have to worry about localizing or like what is the ID. Like it handles all that for me. And I just needed to declare an attribute. And it works more or less. Basically, I look for all the classes that are loaded, and then I see all of them that has this attribute, which of them has this type, and then I use it. But if I just delete it or I want to add a new one, I just need to add this attribute, and it's so cheap to do so. The other example that I use a lot of reflection is to modifying read-only data, which is something you shouldn't do technically, but I do it all the time. So like I have, again, this game assets, and all my game assets, they are read-only, they are immutable. So this is great. This gives me such peace of mind because I guarantee that they are not being modified in the game, because the only thing that modifies is the editor. So like in the editor, I have all these boxes and I modify all of them, and I use reflection to do that because I can just get the name of the field and cheat my way and just get the memory there. And I know that this doesn't happen in the game. And that's pretty much all the 4 things that I want to talk about. So it's yes, code generation, game assets, and reflection. And yeah, I got here. And I hope this at least gave some ideas or some details. And that's the end of the talk.
On the left here.
What are your thoughts on more composition-based object-oriented programming?
So it's basically a way of doing OP, right? So like composition. I think it all depends on the scenario that you have. If that's the best solution for your scenario, I think that's definitely like you should use it. don't think you should never impose rules. You should always just try to think with an open mind, like what's the best answer here.
Fair enough, yeah.
Hi, Isa. Thanks for the talk. As someone who struggled through learning ECS while using Unity, and then I switched over to using your murder engine, and it was so much easier to use because I had struggled through the Unity process. But somebody coming on for ECS the first time, do you have any recommendations on either ways to get used to modularizing their code and getting away from OOP, or any just particular resources you want to call out in self-directed learning?
Yeah, so it's very tricky with ECS because when you're learning, there's all these people in the internet, they are very strict about the rules. And then that was kind of okay, but how games get actually made in this? And I remember there's this Overwatch talk on GDC that they explain how they use ECS and they show all their systems. And I would just pause the video on that one and see how they did every little thing and say, okay, they use that, so I can do something similar. But I think it's mostly just trying things out and not worrying too much about being wrong, just seeing how it works. Because one thing that I found with ECS, there's 4 different ways of doing the same thing most of the time. So you just have to pick one and see what you learn with it.
Good general advice for coding as well, thanks.
On left here.
I don't know if this is a full question so much as kind of a observation as well, but with my experimentation with ECS, it also definitely seems a lot easier to multi-thread later on if you don't start with that in mind because the systems are so separated. Is that what you found too?
Yeah, a lot of people use ECS because of the performance, but I don't use it for the performance because it's like a pixel art game for my case. I mostly use it because it's so easy to work with, but it had a lot of Alan Wake 2. They use ECS heavily and you can see how they change the scenarios. It's so quick. And that's a big performance thing because everything's data. So you can see some of the gains they have there.
Sorry, follow up. I didn't hear you use the term MVC or model view controller pattern, but that's one way I learned to describe the separation of the controller, which is the system, the data, which is the model, and the view, which is the rendering. Any words on that with how you built these systems?
The model view controller, I use that a lot. The one thing I just didn't like when it became too bureaucratic. Sometimes it becomes so bureaucratic, you have all these rules that you have to follow. But I think it's one of those cases that if you think it fits the best thing for your solution, you can do, and then you okay, regret this so much, but you use that as a lesson to use something else, if you think that makes more sense. I don't know if that answers, because it depends so much, it's tricky.
Would you say that the model view controller split is kind of the goal of what you've built, though, is to separate out the data, separate out the systems, and separate out the renderings?
Yeah, it's a bit different because the model view controller, it still has something controlling them and dispatching information. As far as I remember, I might be wrong, but I remember some, if there is someone managing all this data, it's usually you don't want that because it's still being centralized. I can't read.